All right, good evening. We're going to go ahead and start our Zoom session 3 for Survey of Contemporary Mathematics. This week we're only focusing on chapter 6 because you also have a midterm exam that you're responsible for completing. I did send a link for a previous Zoom session that I did, an old one. If you'd like to look at that link to help you prepare for that midterm, you might find some examples on there that will be helpful. But tonight is chapter 6, and we've got quite a few formulas to review, so we're just going to jump right in. Don't hesitate to speak up if you've got some questions along the way. Our first definition is unit cost. This is a lot like finding the unit rate, but we're looking for the cost per number of units. And so we've got a few examples we'll just begin with. It says find the unit cost and round to the nearest cent. So we have 6 ears of corn for $2.85. What I want to know is what is the cost per ear of corn for 1 ear of corn. So we can set that up as cost over the unit. Okay, so I've got $2.85 for 6 ears of corn. So I'm going to divide 2.85 by 6, and I'm going to get a decimal. 2.85 divided by 6. This decimal is as far as it goes. But notice it said round to the nearest cent. When we talk about money, money only goes out to the nearest hundredths place. So I need to make sure that I round correctly here. So let me just review those rules for you. When we round to the nearest cent, that's the second digit past the decimal. But I do have to look at this third number to decide, is this going to be 47 cents or 48 cents? If that third number is 5 or more, it's going to bump up the score. That would become 48 cents. If it's 4 or less, then you let it rest, and that would just stay 47 cents. In this case, it will round up to 47 cents per ear of corn, or we could write that as 47 cents per ear of corn this way. Make sure that you label this. This is money per unit, one number of units. So make sure that you label your answer properly in this lesson. Second example, we've got 15 ounces of cereal for $2.95, but we want to know what is the cost per ounce. If you go shopping, oftentimes at the grocery store, not only will it show you how much that box of cereal costs, but if you look a little closer on that label, it's going to show you how much you're paying per ounce. So you can compare those different size boxes of cereal and see which is the cheaper price per ounce. That would be the better buy. And we're going to talk about that in just a second. So we've got the cost, $2.99 per item, 15 ounces. So when I divide 2.99 by 15, we're going to get a repeating decimal here. It's 0.1993, and that 3 actually just keeps going to repeating decimal. But I don't give money in that way. I've got to show money out to the nearest cent, which is the hundredths place. So I look at the number directly behind it, 5 or more. We're going to round that up. So that would actually round up to 20 cents, and that's per ounce. Okay, 20 cents per 1 ounce of cereal. Okay, sorry about that. All right, next example, it's asking us to find the better buy. We have 20 ounces of salsa for $3.29 or 12 ounces of salsa for $1.99. So we're going to calculate these the exact same way we did example 1 and find out which is the better buy. So we've got $3.29 for 20 ounces of salsa or $1.99 for 12 ounces of salsa. So I'm going to do my division. This decimal comes out to be 0.1645, and this one comes out to be 0.16583, and that 3 keeps going. So once again, this is money, so I'm going to have to round to the nearest cent. The number right behind it is 4 or less, so you let it rest. That's going to be 16 cents per ounce of salsa. Where here That number behind there is 5, so that's going to round up to 17 cents per ounce of salsa. So assuming that the quality is the same, the better buy would be that cheaper cost per ounce. So we would select 20 ounces of salsa for $3.29. Okay, one more of those examples. 13 ounces of shampoo for $4.69, or 12 ounces for $3.99. So we set that up, cost per unit. Cost per unit. We'll divide $4.69 by 13. Our decimal's 0.360769. Over here we get 0.3325. Okay, but it's money, so rounding to that nearest cent, the number behind that's a 0, so we let it rest. That's 36 cents per ounce of shampoo. Whereas here, that's a 2. That's going to stay at 33 cents per ounce of shampoo. So the better buy would be the 12 ounces of shampoo for $3.99. So be able to calculate that better buy the way we did example 1. You're looking for the cost per number of units. So you take the cost, divide it by your number of units to find that cost per unit. All right, in this next example, we're looking for the total cost. If bacon costs $4.59 per pound, okay, that means per 1 pound costs $4.59. Then find the total cost for 3 pounds. So if it's $4.59 for 1, I can find out how much 3 pounds will cost by simply multiplying by 3, and that gives me $13.77. A similar example, if brick costs 98 cents per brick, that means 1 brick is 98 cents. Then find the total cost for 75 bricks. So we're going to take 0.9898 cents and multiply that times 75 bricks, and that will total to be $73.50 altogether. So total, we're going to multiply to find that full price for that number of items. All right, here's a new formula that you need to be familiar with. It's how we calculate the percent of increase or decrease. We take the amount that our information increases or decreases depending the problem, and then we divide that by the original amount. That's going to produce a decimal answer, but because it's a percent of increase or a percent of decrease, you want to be sure to give your answer as a percent. You're going to have to remember how to do that conversion from a decimal to a percent. So I'll review that method with you. So we're going to calculate the percent of increase or decrease on this problem. Your apply will be specific. A lot of times it might ask you to round to the nearest whole percent. So please be sure to read those directions closely and follow those rules that we've reviewed about rounding. So my Trails bike sharing program had about 29,750 members during its second year. That's up from 7,900 members during its first year. What was the percent of increase in the number of members between these 2 years? Okay, so back to that formula we just talked about. Since it's an percent of increase we're looking for, we want to find out how much did it increase. Okay, from year 1 to year 2, how much did that increase? And we'll always find that amount by subtracting those numbers from one another. Okay, so if I subtract, I'm going to get 21,850 members. That is the amount that it increased. Then we always divide that by the original amount. Originally, that first year was 7,900. Okay, so as I do that division, I'm going to get 2.7658 so-and-so. It just keeps going, actually. You can do that in your calculator. But that is not my answer. I want the percent that it increased. So I've got to multiply that number by 100%. Remember, when we multiply by 100, it shifts my decimal 2 spaces to the right. So that becomes 276.58%. Okay? But if you remember back in the directions, it did say round to the nearest whole percent. I want an answer without its decimal parts. So I'm going to look at that number right behind the decimal, 5 or more, bump up the score. So this will actually round up to 277%, rounding to the nearest whole percent. Okay, so follow those directions regarding rounding. Also, this answer is a positive number, so that does indicate an increase, but we need to be sure and label that as an increase. This was a 277% increase. Okay, next example, similar to that. We have a new bridge is reduced the normal 45-minute travel time between 2 cities by 18 minutes. What percent of decrease does this represent? So this time, the time has gone down, it's decreased. So we want to find that amount of decrease. So 45 minus 18 is 27. That actually decreased 27 minutes. And we put that number over the original amount. Originally, that time was 45 minutes. Okay, and as I divide that, I'm going to get negative 0.6. Okay, so remember that's my decimal answer, but I'm going to multiply that by 100% to convert that to a percent answer. So I'm going to shift my decimal spot 2 places to the right. That becomes 60%. Now, it's negative because it's a decrease, but I would really prefer you to write your answer as a 60% decrease and just label it as that. But without that word, you really do need to indicate that with the negative sign. But this really is the best answer, to label it as a 60% decrease. So that's why it's important to label it whether it's an increase or a decrease, and it will tell you in the problem what you're looking for. So just one more time, that formula is the amount of increase or the amount that it decreased divided by the original amount. When you get that decimal, shift your decimal point 2 spaces to the right to get your percent, and then label it an increase or a decrease. All right, 2 more definitions. Markups, okay, this is an add-on to the original price, where discounts take away from the original price. In example 5, it says the markup, find the markup or discount in each problem. So a window air conditioner costs $285. Find the markup on the air conditioner if the markup rate is 25% of the cost. So I just want to know, how much are they marking up this price? This right here is going to be helpful. Remember, we learned that of means to multiply 25% of the cost. Well, the cost was $285. So I'm going to take 25% times $285. If you'll recall from previous lessons, when I'm working with percents, I need to turn them into a decimal or a fraction first. 25% means per 100. So that's the same as 1/4 or 0.25. You can decide which form of that percent that you would like to work with. You can use the fraction or the decimal. I'm going to work with the decimal here. 0.25 times $285 gives me a markup of $71.25. All right, so this is what the air conditioner costs, but it's being marked up 25%. So this answer is the markup amount. Now, that's the answer to this question. But you might encounter a question that wants then, what's the total price of that window air conditioner? If they're about to mark it up, that means we are adding that amount to the original price. So let's say we wanted to find that total cost, then you would add that to $285, giving us a total cost of $356.25. that would be the total new cost that you would have to pay after that markup had already been done. So, you may not be asked to go that far, but make sure that you give the answer that the question asked for. Find the markup for the air conditioner if the markup rate is 25% of that cost. Turn it to a decimal or a fraction, multiply, and that's how we get our markup. That is also the way that we will calculate discount. Okay. And the next example says shoes that regularly sell for $65 are on sale for 15% off the regular price. So think of that as 15% of that regular price of $65. So once again, I'm going to turn that percent into a fraction or a decimal. You work with either form. So 0.15 times $65 equals $9.75. Okay, that is the discount. That's how much is about to be taken off of that original price. Now notice in this problem, it asks for the sale price. What are you going to pay after that discount is being taken off? So we're going to find out what that sale price will be. Markups add to, discounts take away. So you're going to take that $65 and subtract $9.75 from that, and that's going to give us a sale price of $55.25. Okay. If it only asked for the discount, we could have stopped here at $9.75. But it asks us, what is that new price now after that discount is taken off? That would be your sale price of $55.25. All right, here's another question. An outdoor supply store has its regularly priced $160 sleeping bags on sale for $120. What is the discount rate? Now, this word rate means I'm looking for that percent that's off, okay? What is that discount rate? So you can think of that in the same way that we calculated that percent of increase or decrease. That sleeping bag went down in price, okay? So that's going to give me a percent of decrease. So it was originally $160, and now it's on sale for $120. That means the change in price is $40. And I'm going to put that over the original amount of 160. I'm going to divide those. That gives me a decimal of 0.25. Remember, I'm going to multiply that by 100%, shifts that decimal 2 spots to the right, and that gives me a 25% discount. Okay, so that sleeping bag, which was $160, that's now on sale for $120, means it was at a discount rate of 25%. You can check this by multiplying 0.25 times 160, and you should get $40. And if you subtract 40 from 160, then you will get your price of $120. That's just one way of checking your answer. Okay, we've got several other important formulas I'm going to run over with you quickly, and then we'll look at some examples for each of those. Simple interest is calculated by principal times your annual interest rate times your time. And notice that is in years. Okay, we're going to see some problems that give us time as months. So we're going to need to take this into consideration, that it's always represented in years. That's how we calculate interest. The maturity value for simple interest loans is principal plus interest equals the maturity value. So this whole formula that was used to calculate interest will also be used to evaluate this number right here that I can add to the principal to get the maturity value. Okay, so example 6, calculate the simple interest. To finance the purchase of 15 new cars, the rental agency borrowed $100,000 for 9 months at an annual interest rate of 4.5%. What is the simple interest due on the loan? So first of all, I want you to notice that this number right here is not important to me. It has nothing to do with the problem. But these three numbers are. All right, so back up to our formula. We've got principal times rate times time. So that principal is $100,000 times our rate of 4.5%. Now, remember, we can't work with this number as a percentage. 4.5% is the same as 4.5 divided by 100, and dividing by 100 shifts that decimal 2 spaces to the left. You've got to move that decimal over because it's that decimal number that I'm going to use in this formula. You can't just drop the percent and multiply it by 4.5. That will not get you the correct answer. So our interest rate is 0.045, and then we multiply it by the time. Now notice this is months, and in our formula, time is given in years. It's not 9 years, it's 9 months. But you know that there are 12 months in 1 year, so this represents a fraction of a year, 9 months out of 12. So I'm going to use this fraction and multiply it times these numbers to get my answer. So in your calculator, 100,000 times 0.045 times 9 divided by 12, that's how we're going to find our interest. And that's going to calculate to be $3,375. Okay. Principal times rate times time. Here's another. William Carey borrowed $12,500 for 8 months at an annual simple interest rate of 5.5%. Find the total amount due on the loan, that is the maturity value. So back to that formula. Maturity value is principal plus interest. That's how we calculate maturity value. So they gave me the principal. That number is $12,500. Now I need to know the interest, and I will get that by principal times rate times time. Remember, time is in years. So I'm going to multiply 12,500 times rate, 5.5%. Remember, we have to shift that decimal 2 spots backwards. We get 0.055 times our time in years. So 8 months is a fraction of a year, 8 over 12. So this is going to give us our interest. If I do that multiplication, I get $458.33. That is interest. Okay. Now I'm going to add that back to the principal so that I can calculate that maturity value. So I'm going to take this number and add it back here to my principal, $12,500. And that's going to give me a total amount of $12,958.33. That's the maturity value of that loan. So we calculated the interest just like the last example. Turn my percent into a decimal. Time, months over 12. If that was 8 years, I would just plug in 8, okay? But it's months, so I do 8 over 12. That gives me the interest. We add that back to the principal to calculate that maturity value. If anybody has a question as we are going through this, you don't hesitate to jump in with us, but I will also answer any questions you have at the end of our video as well. Okay, example 7 says calculate the finance charges of a credit card bill. A credit card company charges the customer 1.25% per month on the unpaid balance of charges on that credit card. So what is the finance charge for a month in which the customer has an unpaid balance of $118.72? So it's 1.25% per month, okay, on that unpaid balance. And this is the unpaid balance. So once again, I'm going to shift that decimal 2 spots to the left. That's 0.0125. We're going to multiply that times $118.72. And that's going to calculate our finance charge, okay? So 1.484, that's the decimal I get, but remember, money only goes out to the nearest hundredths place. We have to round to the nearest cent, which is the second position past the decimal. But looking at that third number, 4 or less, let it rest. So that's going to stay $1.48. Be really careful to follow those rules for rounding to give the best answer here. So that finance charge is $1.48. Okay, next note is loan origination fee. This is a fee that a bank charges for processing the mortgage papers. Points means percent. So when we see that related to this problem, remember points means percent. So points times the mortgage equals the loan origination fee. Let's look at an example. A loan of $150,000 is obtained to purchase a home. The loan origination fee is 12.5 points. What did we say? Remember that equals percent. So find the amount of the loan origination fee. So I'm going to rewrite that as 2.5%. 2.5 points is 2.5%. As before, we're going to shift that decimal 2 spots to the left, 0.025. Let me go back to that formula. Points times the mortgage, okay? So I'm going to multiply that times $150,000, and that's going to give us our loan origination fee. Calculate that. That will be $3,750. Okay, points means percent. After you change that to percent, shift your decimal back 2 spaces to the left. All right, example 9. A sedan was purchased for $23,500. A down payment of 15% of that purchase price was required. So how much was the down payment? So 15% of the purchase price. 15% times the purchase price. So remember 15%, that's per 100, that's 0.15. So 0.15 times $23,500. All right, that gives me an amount of $3,525. Okay, that's the down payment. All right, keeping going. Physical therapist bought a used car for $9,375 and made a down payment of $1,875. The sales tax is 5% of the purchase price. Okay, so we're going to take 5% of that purchase price, what it was purchased for. So 5% per 100, that's 0.05. 0.05 times $9,375. That gives us a sales tax rate of $468.75. Okay, so this next problem, be careful here. It says find the total cost, not like what is the amount you're going to end up paying for that car, but it just says total up the sales tax and the down payment. Okay, so we're going to just add up how much sales tax was, that was this amount, and then how much was the down payment that was given to us here. So we got $468.75 plus $1,875. Okay, so what is the total of those two amounts? And that would add up to be $2,343.75. So notice here, we're just totaling sales tax and the down payment, not what was be left over when you subtract the down payment and add the tax. That's not what we're looking at here. So just total up those two amounts. You should have a question similar to that on your apply to this week. All right, we're down to just a few extra examples if you can hang in there with us. The code word tonight is discount. So if you're watching this later, make sure to send me a brief summary and include the code word discount to receive your extra credit points. A real estate agent receives a 3% commission for selling a house. Find the commission that the agent earned for selling the house for $131,000. So it's 3% of that price. Percent means per 100. That's like 3 point. So I'm just shifting that decimal 2 spots to the left, 0.03, 300. And then I'll multiply that decimal times the sale price of the home. And that gives me a commission of $3,930. Okay. A stock clerk at a supermarket earns $12.68 an hour for working the night shift. The clerk's wage increases by 15%. So what is the increase in the hourly pay for working that night shift? It's 15% of this amount. So 0.15 times $12.68, that would be 1.902. Remember, this is money, so that's going to round to the nearest cent and be $1.90. That's the answer to this question. The increase, it goes up $1.90. So what is the clerk's hourly wage for working that night shift? So now I'm going to take the $12.68 that he or she normally makes and add that $1.90 extra, and that will give us $14.58 for working that night shift. So here I had to calculate how much does the pay go up and then add that to the original amount to get the new hourly wage for working that night shift. All right, one last example. Joel had a checking account balance of $427.38 before a deposit of $127.29 was made. Joel then wrote 2 checks, one for $43.52 and one for $249.78. Find the current checkbook balance. There is a problem related to checkbooks on the applied. You need to know that debits, as it relates to a checkbook, okay, are transactions that are subtracting from the account, like writing a check or using your debit card. Those take away from your balance. Whereas a credit for a checkbook, those add to. A credit would be like making a deposit into your bank account. So be careful in that question. Make sure you read it carefully as it relates to a checkbook. So originally we have $427.38 in the account. There's a deposit or a credit of $127.29. He writes 2 checks, which are debits. They take away from the account, so we subtract those. So using your calculator, you'll add the deposit, which is a credit. You'll subtract those check amounts, which are debits, and that will give us a new checkbook balance of $261.37. All right, that's our video for tonight. I hope that was helpful. I hope that you see that the apply will be similar to the examples that we've gone over tonight. You'll have a great evening. We're going to stop the video at this time.